So homework 21, going to be working with systems of equations to solve some different kinds of word problems. The first one talks about being a value mixture problem. A lot of times it'll have to do with money and amounts, or in this case milliliters and amounts. But it says here 2 rainstorms occurred in 1 week in a certain area. In the first storm, 40 milliliters of rain fell per hour. In the second storm, 25 milliliters of rain fell per hour. The rain lasted for a total of 55 hours, resulting in a total rainfall of 1,825 milliliters. How long was each storm? So we're looking for how long the first storm lasted and how long the second storm lasted. One of our numbers in our problem on these types of problems is always going to be the total, like we had on those previous word problems. How long was each storm? Well, we know the rain lasted for 55 hours. That's the length of both of our storms. So one of our equations is going to be the length of the first storm plus the length of the second storm is going to be the how long, 55 hours total. The other one is coming in this case from the number of milliliters that fell for each hour. The first storm, 40 milliliters per hour fell, so if I took 40 times the number of hours of the first storm, I'd have the total rainfall. On the second storm, 25 milliliters of rain fell per hour. So if I take 25 times the length of the second storm, I'm going to have how many milliliters fell for the second storm. Tells us that the total number of milliliters for the 2 storms, 1,825. Now you can solve these 2 different ways, either by the addition method, which is the one I prefer, or by substitution. First one I'm going to do by the addition method, and then I'll do the second one by substitution, and then you can decide which way you like better. I want to find both the first and the second storm, so it really doesn't matter which variable I eliminate from my equation. I'm just going to go ahead and get rid of the f's. So I'm going to take everything in that top equation by a negative 40 so that I have opposites in front of my f's. So using my distributive property, I'm going to have negative 40f, negative 40s, and then I'm going to make sure I take that negative 40 times the 55 on the end. So if you grab your calculator and take negative 40 times 55 for me. Negative 2,200?
Yeah.
I now have opposites in front of my f's. My f's will cancel out. 25 minus 40 would give me 25 minus 40 is negative 15s. 1825 minus 2200.
Negative 375.
Negative 375. And then in order to solve that, we're just going to divide. Here we have a negative divided by a negative, which is going to give us a positive answer. Negative 375 divided by negative 15 is?
390. Wait.
25. So that means the storm lasted for the second storm lasted for 25 hours.
Correct in the name?
Yep.
Okay.
We want to find the length of the first storm also. It looks a whole lot easier to substitute into the top equation instead of the bottom one, so I would use the top equation. The first one plus the second one, it's 25, equals 55, right? Because I knew the sum of the 2 were 55. If I subtract my 25, the first one lasted for 30 hours. So look for, first of all, what the question asks, how long was each storm, and then see if somewhere in the word problem there's a total for those 2 values. So number 2 says 2 mechanics worked on a car. The first mechanic worked for 20 hours, the second mechanic worked for 15 hours. Together they charged a total of $3,950. What was the rate charged per hour by each mechanic if the sum of the two rates was $225 per hour? So what is the rate charged per hour by each mechanic? And right there they tell you the sum of my two rates is $225. So what's my equation going to be? How am I going to show the sum of my rates is $225? Sum means I'm going to add the rate of my first mechanic, which we don't know, we'll call F, plus the rate of my second mechanic, I'll call S. So F plus S is the total of the two rates, $225 per hour. Second equation going to have to do with how much money they're going to make. The first one worked for 20 hours. So if I take 20 times the rate he makes per hour, we're going to find out how much money he made. The second mechanic worked for 15 hours. So if we take 15 times the rate he gets per hour, we're going to find out how much money he made. Together they charged $3,950. Now we did the first one by the addition method. I'm going to do this one by the substitution method because some people like one way better than the other way, and we're all a little different. I'm going to go ahead and solve this equation for F. So I'm going to move the S to the other side. So I'm going to minus the S. So F is going to equal 225 minus S. So if I'm going to solve this by substitution, I'm now going to replace the F in this second equation with the 225 minus S. So I'm going to have 20 parentheses, 225 minus S, plus 15S equals 3950. So I've just replaced the F here like we did with the substitution method. So now I have to do my distributive property. If you grab your calculator, 20 times 225. 2,500 you said? 4,500? And then 20 times minus S then would be minus 20S. Plus 15S equals 3950. So combining my like terms, and just because I like my variables in front, negative 20 plus 15 would be negative 5S plus 4,500 equals 3950 then. So if I want to solve that for S, the next thing I got to do, subtract my 4,500. So negative 5S equals 500, or negative 550, right? And then I'm going to divide by negative 5. So S is going to equal 110. The second mechanic is charging $110 per hour. We still have to find the rate of the first mechanic. We're going to do that by substituting into this equation that we solved for F. F is going to equal 225 minus the second one, which was 110. And so if you subtract that, you get $115, right? So the first guy charged $115 an hour, the second one $110 an hour. Wish I made that. that's if you want to do it by the substitution method. You can pick whichever method you like better. All right, so number 3 on homework day 21 had a typo on it, so it wasn't working very well. That should have been 35 miles an hour up there for the fuel efficiency of the first car. So it says a family has 2 cars. The first car has a fuel efficiency of 35 miles per gallon of gas. The second one has a fuel efficiency of 30 miles per gallon of gas. During one particular week, the 2 cars went a combined total of 2,425 miles for a total gas consumption of 75 gallons of gas. The question says how many gallons were consumed by each of the 2 cars. So we know that on these types of problems, one of your equations is always going to come from adding your 2 unknowns together. It tells us that we're looking for how many gallons each of the cars used, and it told us the total gas consumption was 75 gallons. So one of our equations is that if you take the gas consumption from the first car plus the gas consumption of the second car, you're going to get 75 total gallons between the 2 cars. Our other equation has to do with the fuel efficiency, and if I go 35 miles per gallon and I used so many gallons of gas, that's going to tell me how many miles I drove. So the first car has a fuel efficiency of 35 miles per gallon, and we used F gallons of gas. The second car had a fuel efficiency of 30 miles per gallon, and we used S gallons of gas. Total number of miles the 2 cars went was the 2425. So after we set up our systems of equations on those, we said, oh, we got to eliminate one of our variables from our systems of equations, and that we could either do it by substitution or addition, and you guys seem to think that addition was the easier way, which is also what I think. You can either get rid of the F's or the S's. It doesn't matter. Which one would you prefer to get rid of on this one? The F? Okay. If I'm going to get rid of the F, I'm going to multiply by the opposite of what's in front of the F, so I'm going to multiply everything in that top equation by negative 35 then. And then I'm going to use my distributive property. So negative 35 times F, the negative 35 times the S, and then we have to take negative 35 times 75. Multiply that again. 35 times 75. Ah. So negative 2625. Since I have a negative times a positive, I'm going to get a negative down there. Now that I have opposites in front of my F's, I can add my equations together. So the F's are going to cancel out. 30 minus 35 would give me negative 5S. 2425 minus 2625 would be a negative 200. And so in order to solve that, all we need to do is divide. If I divide by my negative 5, S is going to equal, I have a negative over a negative, so it should be positive, right? I hopefully don't have a negative 40 gallons of gas. My second car used 40 gallons of gas. I still want to find out how much the first car used. You could substitute it into either one of my original equations, but the top one's obviously easier. And so I'm going to say the first plus the 40, which is the second, is equal to 75. Then all we need to do is subtract to solve that. So the first one used 35 gallons of gas. So that's what that one was supposed to be, but I evidently can't read or type. One of the two, I messed up one of those numbers. So it should have been a 35 up there instead of the 24 that's on your paper. All right. Then we had to go all the way down to, it must have been number 11 where we left off. Number 4, we'll see if this one comes out any better. Now this one's going to be a percent mixture problem, but going to look pretty close to what we just did on the previous ones, but this time we're going to use some percents. So we want to think about that if I take the percent times the amount, I get the pure substance in there. It says a petroleum company has two different sources of crude oil. The first source provides crude oil that is 50% hydrocarbons. The second one provides crude oil that is 75% hydrocarbons. In order to obtain 120 gallons of crude oil that is 65%, how many gallons of crude oil must be used from each of the two sources? So I want to think about, if I have a table here, that if I take the percent times the amount, it's equal to the pure substance that I have. The first one is 50%. The second one is 75%. And I want to get 120 gallons of a crude oil that is 65%. So if I add my total, I'm going to have 65% that is 120 gallons. So I don't know how much of A I have, I don't know how much of B I have, but if I take 50% of A and 75% of B, I'm going to get 65% of my 120. What's 65% of 120? If you take 0.65 times 120, I'm going to get 78. So when I do my two equations, one of my equations is usually going to come from adding the amounts together. One of my equations is going to come from adding the pure substance together. So one of my equations is just that A plus B equaled the 120. Whatever we had of A plus whatever we had of B made the 120 that we had all together. My other equation comes from my percents. 50% of A plus 75% of B is going to equal my 65% of 120, which we said was the 78. And so again, we can solve by either addition or substitution. I like the addition method better. So I'd probably just take my top equation times negative 0.5 so that we can eliminate the A's there. So negative 0.5 times A would be negative 0.5A. Negative 4.5 times B would be negative 0.5B. And then if we take negative 0.5 times 120, we get something like negative 60, right? 0.5 is half of 120 is 60. So now I can add my equations together. I have opposites in front of my A's, they're going to cancel out. 75% minus 50% would be 25%, 0.25B. 78 minus 60 would be 18. And so in order to solve that, we're going to divide by 0.25. So if you take your calculator and take 18 divided by 0.25, you get 72. 72 would make some sense. So we know we had 72 gallons of B. We want to also know how much we have of A. Well, again, we knew that the total was 120. So if we take A plus 72, we get 120. And all we really need to do is subtract then. What was that?
48.
48. So A is going to equal 48 gallons. So we have 48 gallons of A and 72 gallons of B. So, the Royal Fruit Company produces two types of fruit drinks. The first type is 40% pure fruit juice. The second type is 90% pure fruit juice. The company is attempting to produce a fruit juice that contains 75% pure fruit juice. How many pints of each of the two existing types of drink must be used to make 150 pints of a mixture that is 75% pure fruit juice? So our two types, tropic, tangy, and very good. I'm going to use T for that one and B for that one just for fun. Tropic, tangy, very good. So our first equation coming from our amounts. You can make a table if you want to make a table. I don't know that you really need to. But if I look at my amounts, the sum of my two amounts is going to be?
So T plus B equals 150?
Exactly. The amount of T plus the amount of B is going to be equal to 150 pints that we had all together. Then doing our equation from our percentages, we're going to have what?
Okay, 0.40 T.
0.40 T, or you could just use 0.4. It's the same thing as 0.40.
Wait, plus 0.75 B equals 150? Right?
No?
No, equals, I don't know.
How did we get that N number before? How did we get the 78, I think it was, on the previous problem? We have 150 pints, that is 75% juice. So we have to figure out what is 75% of 150. So 75 times, or 0.75 times 150 is 112.5. So this is going to be 112.5 because it's the amount of pure juice that we have. The rest is probably water and sugar and some other additives. So if we want to solve this by the addition method, we're going to take our top equation times negative 0.40 so that we can make opposites. I don't know why I write that line there because I'm going to have to do my adding to that. So, multiplying that out, negative 0.40 T, negative 0.40 B equals, what's negative 0.40 times 150?
Negative 60.
Negative 60. Adding our equations together, the T's are going to cancel out. 75% minus 40% is 35.35 B, right? 35% of B. 112.5 minus 60.
52.5.
52.5. So in order to solve that, we're going to divide by the 0.35.
150.
150. 115?
150.
It came out to 150. 52.5 divided by 0.35. That means we have none of the other one. Oh, wait a minute. No. Never mind, we have our equations wrong. I better pay a bit more attention. We could have 0, but we won't. Because this number right here wasn't supposed to be 75%. How much, what percent was type B?
Oh crap, 0.90.
90. That's why that's not working out right. It's always good to look at your answers to see if they make sense. Now we get to try that again. Gosh, it must be Monday today. So, bottom equation should have been 40% of T, 90% of B equals 112.5. And then we can still multiply by our negative 0.40. So negative 0.40 T minus 0.40 B equals, what was that, negative 60? Is that what that number was?
What?
Negative 40 times
Yeah.
150? All right. So when we add, 90% minus 40% is going to be 50% of B. 112.5 minus 60 was 52.5.
Yeah.
Now if we divide by our 0.50, B equals 105. I didn't think the full amount was going to be all 150. We know that the sum of our two was 150, right? So T plus 105 equals 150. How much does that leave for the tangy tropic tangy?
55.
How about 45? So 45 pints of tropic tangy and 105 pints of very good. All right, number 6, same kind of thing. A chef is using a mixture of 2 brands of Italian dressing. The first brand contains 6% vinegar. The second brand contains 10% vinegar. The chef wants to make 320 milliliters of a dressing that is 7% vinegar. How much of each brand should we use? How much? So, our first equation is going to be
F plus S equals 320.
F plus S equals the 320 milliliters we had all together, right? Our second equation, using our percentages, we're going to have what?
0.06 F
6% on the first plus
0.1 S
0.1 or 0.10 S, whichever way you want to write it, 10%, equals, how do we get that in number? This is day 21 on the chapter 3 packet. Yeah, chapter 4 one. So there's another packet over there. What did we do to find that n number on our second equation? $224. How'd you get 224?
Times the 320 by 0.7.
320 times, not 0.7, because that'd be 70%.
Wait, 0.07.
0.07.
Okay, hold on. Let me do that.
Okay. Right, we got to take our amount times our percent.
22.4.
So 22.4. The 7% is not very much, right? I did that again. I keep wanting to draw a line underneath there. I don't want my line underneath there. So if I want to get rid of my F's, I'm going to multiply the top equation times
6%.
or
0.06.
negative, right?
Yeah.
0.6%. Negative 6%, so that I have opposites in front of my F's. So what's my new equation going to be?
Negative 0 or 0.06 F plus negative 0.6 S equals
What was that? Negative 19.2? So 6% or negative 6% times F, negative 6% times S, negative 6% times my 320, which is negative 19.2. So when we add our equations together, the F's cancel out. 10% minus 6% is 4%, so 0.04 S. 22.4 minus 19.2. 3.2, and then we end up having to divide.
80.
S equals 80. S equals 80. So we had 80 milliliters of our second one. How are we going to find out how much of the first one we had? we're going to say that F plus 80 equals the 320 total, right? The first one plus the second was 320. We know the second one is 80. So if we subtract 80 from 320, 240, we have 240 milliliters of the first one.
What was the top one?
240?
And then the very goods is.
Oh, 80. Oh no, you're doing, that wasn't that one. That was this one. That's this one down here. So the first one was 240, the second one was 80. The next one has to do with solving distance, rate, and time problems. We know that rate times time equals distance. Right? If we go 50 miles an hour for 3 hours, we got 150 miles. So on these first ones here, we're going to have things where we're either going against the wind and with the wind, or upstream and downstream, where something's pushing against us, making us go faster or slower. So our rate is going to have two different things. A cyclist travels 22 miles in 2 hours going against the wind. She travels 42 miles with the wind in the same amount of time. What is the rate of the cyclist in still air? What is the rate of the wind? So we have two different things. We have the rate of the cyclist and the rate of the wind. I'm just going to use a C and a W to keep track of which is which. If I am going against the wind is going to blow against me and slow me down, right? It's harder to ride my bike into the wind. So my overall rate is going to be the cyclist minus the wind if I'm going against the wind. That's my rate. Times my time. My time here is 2 hours to equal the 22 miles. Now what they're going to do with that equation is they're going to go ahead and divide by that 2 right away to get the C minus W by itself. So they're going to go ahead and divide by 2 and say that C minus W then equals 11. Then they're going to do their second equation. She travels 42 miles with the wind in the same amount of time. If I'm going with the wind is pushing against my back. In theory, it's going to make me go faster. So my overall rate is going to be C plus W, because the wind is going to speed me up. Same amount of time, so I'm still going to go 2 hours, but this time I went 42 miles altogether. Again, they're going to go ahead and divide right away to get the variable by itself, so we're going to divide by the 2 and say that C plus W equals 21. Now that kind of looks like that problem where we had the sum of two numbers is and the difference of two numbers is, right? We have opposites in front of our W's, so we can just go ahead and add to eliminate the W's from our equations. C plus C is 2 C's. Negative W and a plus W cancel out. 11 plus 21 is 32. In order to solve that for C, all we have to do is divide. C is going to equal 16. So the rate of the cyclist, 16 miles an hour. We again need to find the rate of the wind. Personally, I think it's easiest to put it in with the plus one. We did the one with the minus before. If I do the plus one, I would say 16 plus W equals 21, plugging it into that second equation. And all I need to do to solve that is subtract, right? So 21 minus 16 gives me 5, right? So the wind is going 5 miles an hour. So number 8 is going to look really similar to number 7 here. A motorboat takes 4 hours to travel 192 kilometers going upstream. The return trip takes 2 hours going downstream. What is the rate of the boat in still water? What is the rate of the current? So I'm going to use B for boat, C for current. Use something that makes sense to you so you know which answer goes where. Motorboat takes 4 hours to travel 192 kilometers going upstream. So if I'm going upstream, am I going to go faster or slower? Slower, because it's harder to go uphill, right? So my overall rate is going to be B minus C, the boat minus the current. The time on that one is
4 hours.
4 hours. The distance is
192.
192 kilometers. So my rate times my time equals my distance. Again, they're going to go ahead and divide by that 4 right away. So if you go ahead and divide that by 4 for me, B minus C is going to equal
48.
48. My second equation on my return trip takes me 2 hours going downstream. So if I'm going downstream, am I going to go faster or slower? I'm going to add because I'm going faster, right? In theory, if I go downhill, I should be going faster than if I'm going uphill. This time my time is
2 hours.
2 hours and my distance is
The same.
the same. Whoops, my card got full. Nope, I'm still recording. That's your phone. I thought that was this thing. It makes music at me if I run out of space. So again, they're going to go ahead and divide by that 2 right away. So that B plus C is going to equal 96. So again, now I have one difference and one sum. I can just go ahead and add those together. If I add my 2 equations together, I'm going to get
2B equals 144.
2B equals what?
144.
144. And if I divide by 2,
72.
the boat is going 72. 72 kilometers per hour. If I want to find how fast the current is going, where might I plug that in?
And B.
In for B, do we want to use the top equation or the bottom equation?
The top one.
The top one? Okay, we'll use the top one this time. So we would say 72 minus C equals 48. If I'm going to solve that, I would first
Subtract the 72.
subtract the 72. So negative C is going to equal
24.
negative
24.
negative 24. Then I end up having to divide by negative 1. So C equals positive 24. So the boat is going 72 kilometers per hour, the current 24 kilometers per hour. Now, the next ones are still using that rate times time equals distance, but now they're not going to be going against and with something, and they mix these 2 kinds of problems together. I don't know why, but they did. But what we want to think about is what's happening here. 2 buses leave towns 228 miles apart at the same time and travel toward each other. One bus travels 16 miles an hour faster than the other. If they meet in 2 hours, what is the rate of each bus? I like to draw pictures. 2 trains leave towns 228 miles apart at the same time, and they're traveling toward each other. So one's going this way, one's going this way. I know the whole distance is 228. So if I'm going to find the distance of each person or each bus, I need the rate and the time of each of those. So it says one travels 16 miles an hour faster than the other. So I'm going to call the rate of one of them R, because I don't know it. How would I write the rate of the other one to show that it's going 16 miles an hour faster?
Multiply. All right.
Faster. I'm doing 16 miles an hour faster than the other one.
Add.
I'm going to add the 16. So one of them's rate is R, the other one's rate is R plus 16. Now, we have a faster bus and the slower bus. The faster one is obviously the one with the plus 16, right? So this one's rate is R plus 16, and this one's just the plain R. The time, they both meet in 2 hours. That means one went for 2 hours and the other one went for 2 hours. So this one is going to go for 2 hours at R plus 16, and this one's going to go for 2 hours at the rate of R. Rate times time equals their distances. If I add the two distances together, I should get the 228 miles that they are apart, right? So 2 times R plus 16 plus 2R is going to equal 228. And now I have my equation. And I got to go through all the work of solving that. So using my distributive property, 2R plus 2 times 16 would be 32, plus 2R equals 228. Combining my like terms, 2R plus another 2R would be 4R, plus 32 equals 228. To solve that, I got to minus my 32. I'm going to let you do that for me. What was that? 196? 4R equals 196. If you get a different number, holler. What? And if you divide by 4, she's just way ahead of me. 49, you said? So, this one is going to be going 49 because that rate was just the plain R, right? The slower one. The other one is going to go R plus 16, so we're going to have to take 49 plus 16. And 49 plus 16 would give me 65. So that bus is going 65 miles an hour, the other bus is going 49 miles an hour. Better talk really fast. I got behind when I had that messed up problem. 2 buses leave the station at the same time and travel in opposite directions. So, one's going this way, one's going that way. One bus travels 12 kilometers slower than the other. If the 2 buses are 654 kilometers apart after 3 hours, what is the rate of each bus? So again, we know that they're 654 miles apart. We want to write something to represent their rates. One of them we're just going to call R, and the other one would be what?
R minus 12.
R minus 12, because it's going 12 kilometers per hour slower, right? R minus 12. Now, obviously, the slower one is the one with the subtraction, and so the faster one's going to be your plain R. So, they're both going to go for 3 hours, so I'm going to take 3 times R minus 12, and then the other one is just going to be 3 times R. We know if we add their 2 distances together, we should have the total distance of 654. So 3 times R minus 12 plus 3R equals 654. Using my distributive property, 3R minus 36 plus 3R equals 654 then. Combining my like terms, 3R plus 3R would be 6Rs. 6R minus 36 equals 654. I got to move my 36 to the other side, so I've got to add it this time, right? It's a minus 36, I got to make it a plus 36. So 6R is going to equal 690, thank you. And dividing by 6, R equals
115.
115?
Yeah.
115?
Yeah.
So that is going to be the rate of the faster bus. Holy cow, he is going fast, 115. The rate of the slower bus then I'm going to subtract 12 from that. Oh, that's supposed to be kilometers per hour. That's why it looks really fast. I was going to say, if he's going 115 miles an hour, that's really fast. But kilometers per hour would make more sense. It said kilometers up there. R minus 12, so 115 minus 12 would be 103. All right, we're going to save the other ones for Wednesday because we only have one homework page to do on Wednesday. So we'll finish this up Wednesday and then do the next homework page. And we'll have all of Chapter 3 done. And I got to figure out what that other problem was supposed to be. So number 11, solving tax rate or interest rate problems. And most of these you'll set up one equation that's F equals or S equals something, and then we're going to substitute in to solve these ones. It says John bought 2 computers, one desktop, one laptop. I'm going to use D for my desktop, L for my laptop, because I like to use variables that make sense to me. Before finance charges, the laptop cost me $1,000 less than the desktop. When you're translating those sentences, whatever one is mentioned first is the one you're going to set equal to something. The laptop costs. The laptop is $1,000 less than the desktop. How do I show $1,000 less than the desktop? I'm going to subtract. I'm going to take the desktop minus the 1,000, right? The minus has to go on the end because the desktop should cost more than what you're going to take away. Then I'm going to write my second equation, which has to do with some percents in there. John paid for the computer using 2 different financing plans. For the desktop, the interest rate was 5% per year. So I'm going to have 0.05, 5% of the price of my desktop, D. For the laptop, it was 7.5% per year. So 0.075 on my laptop was the interest. The total finance charges, or the total interest for 1 year, was $487.50. So this one, since we already have that top equation solved for L, is just as easy to solve by substitution instead of having to rearrange it to solve it by the addition method. So we're going to take this expression, the D minus 1,000, we're going to put it in the place of the L. So we're going to get rid of the L from there. And so if I rewrite that second equation, I'm going to have 0.05D plus 0.075, and in parentheses, I'm going to replace the L with D minus 1,000. Equals my 487.50. Now I have an equation that only has one variable, and I can go ahead and solve that. So 0.05D plus, using my distributive property, 0.075D, and then I got to take 0.075 times negative 1,000, which should be negative 75, because if I'm multiplying by 1,000, I just move my decimal 3 places, or I use my calculator, equals my 487.50. Since I have like terms, I can go ahead and combine my like terms. If I take 5% plus 7.5%, I'm going to have 12.5%, right? So 0.125D minus 75 equals 487.50. Points up kind of high. Well. In order to solve that, got to move my 75 to the other side, so I'm going to add my 75. 0.125D is going to equal, and what's 487.50 plus 75? $562.50. And then in order to solve that, all I'm going to do is divide by my 0.125. 3,500, you said? 4,500? So my desktop D is $4,500, 4,500. I still need to find the price of my laptop. In order to find my price of my laptop, I'm going to go to this very first equation that was already solved for the laptop. The laptop was $1,000 less than the desktop. So if I take $1,000 off my $4,500, my laptop's going to be $3,500 then. So these ones are all going to be very similar to this one here, as far as setting them up and what they're going to look like when you solve them. So number 12 says, a theater group made appearances in 2 countries. The hotel charges before tax in the second country were $1,500 higher than in the first country. The tax on the hotel bill was 9.5% in the first, 4.5% in the second. After the trip, the total tax paid on accommodation expenses was $662.50. How much was the hotel bill in each country before tax? So I'm going to use F for my first one and S for my second one. If I want to take that second sentence and translate that, the hotel charges before tax in the second country were $1,500 higher than in the first. What should I have for my equation? I'm going to add, and what am I going to start with?
S plus 1,500.
Which one plus 1,500?
Oh, F.
F plus 1,500. So the second one is mentioned first. So I'm going to have S equals something. The second one were or was or is or whatever verb they want to use there. 1,500 higher than the first means I'm adding 1,500 to the first. So S is equal to F plus 1,500. Then I have my percentages. The tax on the first was 9.5%, so 0.095 on the first. The tax on the second was 4.5%, so 0.045 on the second. My total tax is $662.50. So again, I'm going to solve by substitution. I'm going to replace the S with the F plus 1,500. So I'm going to get rid of this. I'm going to put that in its spot. And I'm going to have 0.095F plus 0.045S times F plus 1,500 equals $662.50, so that I have the same variable in my equation. So 0.095F, using my distributive property, what do I have that S back there for? It shouldn't be there. 0.045 times F, 0.045F, plus, I'd have to take 0.045 times 1,500. .045 times 1,500 would give me 42 point what? 42.5? Oh, 142.5. 142.5. So again, I'm going to go ahead and combine my like terms here. If you add the 9.5% plus the 4.5%, what would you get?
0.14.
So 0.14 F plus 142.5 equals 662.50. Solving that for F then, I got to move my 142.5 to the other side. Since the plus, when I might move it over, I got to subtract it. So I'm going to subtract my 142.5. Multiply this out for me again, because I'm getting a different number.
67.5.
That's what I'm getting. We might as well fix that before we get too far. 67.5. That one something sounded kind of big, but 67.5. All right, so we got to subtract our 67.5 when we move that over. So 0.14F is going to equal 662.5 minus 67.5 would be 595. And then we're going to divide by our 14%. So divide that 5.14. 4,250. So the first is $4,250 for my hotel charges for a week. In the second country then, I'm going to find the second country. I'm going to go back here to that very top equation. It says it's the first plus 1,500. So if we take our 4,250 plus 1,500, we get 5,750. All right, one more of those. Oh, no, two more of those, evidently. John bought 2 computers, 1 desktop and 1 laptop. Before finance charges, the laptop cost $1,000 more than the desktop. John paid for the computer using 2 different financing plans. For the desktop, the interest rate was 6% per year. For the laptop, it was 7.5% per year. Find the total finance charges for 1 year were $885. How much did each computer cost before finance charges? So if I use D for my desktop and L for my laptop, the second sentence there says before finance charges, the laptop costs $1,000 more than the desktop. So my equation should be
L times D.
no. The laptop costs $1,000 more than the desktop.
1,000 plus D.
1,000 plus D. So the laptop L costs 1,000 more than the desktop. So D plus 1,000. Right? 1,000 more. I'm adding 1,000 to the desktop. Again, we have 2 different financing plans. For the desktop, it was 6%, so 0.06D. For the laptop, it's 7.5%, so plus 0.075L. Total finance charges, $885. So again, we're going to solve by substitution. We're going to replace the L with our D plus 1,000. So L is equal to that. We're going to get rid of the L, put the D plus 1,000 in its spot. So 0.06D plus 0.075 times D plus 1,000 equals 885. Then have to get rid of my parentheses, so I use my distributive property. 0.06D plus 0.075D. If I take 0.075 times 1,000, I get
750.
plus, did you multiply that?
Yeah.
0.075 times 1,000.
75.
75 equals 885. Must have forgot the 0 or missed the 0 when you typed it in. going to combine my like terms.
I am.
So I'm going to take my 6% plus my 7.5%, and I'm going to get
0.135.
0.135. D plus 75 equals 885. So if I want to solve that for D, the next thing I'm going to do is subtract my 75. 0.135D is going to equal 810, right?
Yeah.
And then I'm going to go ahead and divide by my 0.135. So if you take 810 and divide it by 0.135,
6,000.
6,000. So my desktop, $6,000. I don't know what kind of desktops they're paying for, but they got spendy products. more expensive than I'd buy. My laptop is going to be 6,000 plus 1,000, because we go back to this first equation, and so 6,000 plus 1,000 would be 7,000. Now I found one that looked a little bit different, and so that's why I threw this fourth one on here, so that if you run into one that looks like this, you'd have an example. It says last year Kareem had $20,000 to invest. He invested some of it in an account that pays 9% simple interest per year, and he invested the rest in an account that pays 7% simple interest per year. After 1 year, he received a total of $1,700 in interest. How much did he invest in each account? These are going to be more like those first ones we did. We're looking for how much he put in each account. We have the total of what he put in his two accounts, so we're going to say what we have in the first plus what we have in the second is equal to the 20,000 we had to invest. Instead of them telling you one was $1,000 higher or lower, they gave us the total that he had. He invested some of it in an account that pays 9%, so 9% on the first. The rest in an account that paid 7%, so 0.07 in the second. And he had a total of $1,700 for interest that he received for the year. So these once again are going back to that addition method where we can eliminate either the first or the second one. It doesn't really matter. You guys seem to prefer to get rid of the first one, so we'll get rid of the first one. We're going to take that top equation, and what should we multiply it by? Negative 0.09, right? So that we have opposites in front of our f's. So negative 0.09. So when we're doing that elimination method, we try to make opposites so that when we add, we can cancel them out. So we have negative 0.09f. We'll also have negative 0.09s. And then we have to take negative 0.09 times that 20,000 on the end. I'm getting negative 1,800. How about you guys?
Yeah.
All right. So when we add our equations together, the f's are opposite. They're going to cancel out. 0.07 minus 0.09 would be negative 0.02s. 1,700 minus 1,800 would be a negative 100. And then all we have to do to solve that is go ahead and divide. If I take a negative 100 and I divide it by negative 0.02, how much did I put in my second account?
Negative 5,000?
Should be positive because I have a negative over a negative, right?
Yeah.
So 5,000. So we put $5,000 in our second account. We still need to go back and figure out how much we put in our first account. So much like those other ones where we had that adding, we substituted that in that first equation and said, well, the first one plus the 5,000 from the second one had to equal the 20,000 that we had to invest. And so if we subtract 5,000, we must have put 15,000 in our first account. Alrighty, I'm going to have to go ahead and work till about 10 o'clock and then we'll do day 22.